Okay, floating point data types. So these are decimal data types where you want to express a decimal number. So floating point numbers or floats refer to real numbers. Numbers with a decimal point. Examples are like this, like this, like this, and so on with decimal points. A real number will have the form, we can express a real number as either plus or minus, and then we talk about like a mantissa, which is like the um, decimal representation of it, I guess, and then times 10 to the e, where e is the exponent for the 10, it's the power of 10, and it's a signed integer. So it's either positive or negative, and an integer. Okay, and n is called the mantissa, normalized in binary to be between 1 and 2. So it's going to be between 1 and 2. Okay, for instance, the binary numeral 21 over 16 is 1.0101, which equals 1 plus 1/4 plus 1/16. All right. The single data type is available for low precision floats. So if you don't need too much precision, you can declare something as a single. And that will be stored as a string of 32 bits or 4 bytes. And it's called single precision. According to IEEE standards, that's like an organization that tries to make conventions or standards for this. A single is a 32-bit approximation. So here it is. We saw this before. The first, so we have 32 bits. Each one of these is a bit, and we're going to have the first bit is going to be to tell us whether the number is positive or negative, and the next whatever number of bits, I think this is 8 bits, it's going to tell us the power of 10 that we're going to use, and then this is going to be the decimal part of it, decimal representation of it, which will be between 1 and 2. So bit S encodes the sign. 0 means positive. Bits E, these bits, encode the exponent. We have 8 bits, so it's a signed integer. And then we have these bits encode the mantissa, and there are 23 of these. So the range for negative values is minus this to that, and for positive values, it's from here to here. Okay, now we can talk about floating point, the double. Now we can talk about doubles. It's still floating point data types, and the so-called double precision. Here, a real number is approximated using 64 bits. Again, we have the basic IEEE format here like this. So we have S, then a bunch of E's, then a bunch of M's. But now we have, of course, we still have the first bit is for the sign, but then we have 11 exponent bits, and which are the E's, and 52 mantissa bits, which are our significant bits, which are the M's. And now we have a range from here, e to the 300, and e to the 300 here. This is minus and plus. So minus and plus here. And then we have the decimal data type is also available for floats. The float is stored as a signed 16-byte integer, 128 bits. The integer is then scaled by a power of 10 to produce the float. This specifies the number of digits to the right of the decimal point. The scale is from 0 decimal places to 28 decimal places. Useful for fixed point calculations like currency, money. Okay, then we have the Boolean data type. I said it's only true or false. Although simple, such Boolean values become very important when making decisions. Remember, we saw the flow chart where we had to do yes and no. So it could be true or false, or we have what we call conditional statements, like if something, then we do one thing. If not that thing, then we do something else. Here's an example of declaring a Boolean. You just say dim, and then here's the variable name called isReady. As we say it's as Boolean type, and here we're initializing that to false. So isReady is being set to false. So this declares a Boolean value isReady and initializes it to false. Okay, now we have characters. A character refers to a single symbol. For example, this, or this, or this, or this, or this, or this. In VB, a character is stored via the char data type as a 2-byte. So char uses 2 bytes, unsigned integer 16 bits. So the range is between 0 and here. So that's kind of the set of underlying values that it can take, but it's going to be set to values like this. Okay, that's not a number. It's just we're just saying that's the set of values. And if we have 16 bits, we can express this many different values. For a given character, this integer uniquely identifies the represented character. This is called the Unicode representation. So there are other ways to, represent. So suppose A, we're using 2 bytes, in other words, 16 bits, and maybe A is 16 bits, so I have to specify all 16. So suppose it's 0, 0, 0, 0, 0, 0, 0, 0, all the way to 0 till the first bit is 1. Maybe that stands for A. Okay, so for a given character, this integer uniquely identifies the represented character. This is called the Unicode representation. Conversely, a character of type char may take this many distinct values, each of which is the corresponding unique character. Char variables are useful in processing strings. A char variable is declared like this. So dim the name of the variable as char, and then set it, if you like, initialize it by setting it equal to some character. Note that when assigning a value to a char, I think that's the right pronunciation, by the way, I'm not absolutely sure. That's what I usually use, char. The assigned character is enclosed by double quotes. So here you see double quotes. Example, 1 character equals A. And strings. A string is a collection of characters enclosed by quotation marks. For example, this. A string is declared in the normal way. So dim the name of the string as a string, and then you can initialize it with a particular string value. As usual, initialization is shown, but not as usual. Initialization is shown here, but it's not required. As expected, we may assign a value to a declared string. For example, we could just declare C as a string, and then later on we can assign a string value to C. Such strings are often passed for graphical use, for instance to a button as its text for display. Okay, we'll come back to this next. Working with strings concatenation. So if you want to put 2 strings together, like you have one string this and another string like this, you want a single string that is this. How can you put together these 2 strings? You do it like this. So here's S1, here's S2. You can use this thing to put them together and call that a new string. Okay, we'll come back to this next.